All right, let's talk about one of the most surprising and honestly, one of the coolest comebacks in all of tech: analog computing. Yeah, you heard that right. The stuff we all thought was a museum piece might actually be the key to solving some of our absolute biggest challenges today. For the last 70 plus years, this has been the gospel truth. The entire world runs on digital. Your phone, your laptop, the internet, the whole shebang is built on a simple foundation of ones and zeros. It really seemed like the debate was over, settled for good. But what if that discussion wasn't actually over? Because quietly, in labs and startups all around the world, that very discussion has been reopened. It turns out the problems we're facing today are pushing our digital world right to its absolute limits, forcing us to take a serious second look at this supposedly obsolete technology. So, to really get why this is such a big deal, we got to go back in time a little bit. Why did we put analog computers in a museum in the first place? Why was it considered a technological dead end for so long? Yeah, this was the laundry list of problems with analog, right? Its calculations could drift if the temperature changed by a degree, it was susceptible to electrical noise, and you couldn't just write one program and run it on a million different machines. Digital, with its perfect bit-by-bit precision, was just way more reliable and a heck of a lot more flexible. Okay, so while digital was taking over the world, a tiny crack was forming in its foundation. And now, in the age of AI, that crack has turned into a full-blown crisis. The real problem here has a name. It's called the von Neumann bottleneck. So, in pretty much every digital computer, the processor, the brain, and the memory are physically separate. Think of it like a brilliant chef trying to cook in a kitchen where the pantry is down a long, narrow hallway. The chef is constantly screaming for ingredients, and you have these runners just sprinting back and forth, nonstop. That traffic jam of data, it wastes an incredible amount of time and, crucially, burns an insane amount of energy. And when I say insane, I mean it. Just look at this number. Data centers, the engines behind our cloud, and all this new AI are on a trajectory to eat up 8% of all global electricity by 2030. That's not just a lot, that is fundamentally unsustainable. And this chart just lays it all out, plain as day. Look at the energy required for digital AI. It's this massive bar. Now, look at the promise of analog. It's that tiny sliver. We're talking about doing the same kind of work for a tiny, tiny fraction of the power. This isn't just a small step up. It's a potential revolution in how we think about efficiency. So how on earth is analog so efficient? Well, it all comes down to a totally different philosophy, a different way of thinking about what a calculation even is. See, instead of faking reality by chopping it up into millions of discrete ones and zeros, an analog computer literally becomes a physical model of the math problem it's trying to solve. It embodies the math in its very circuits. I love this way of thinking about it. A digital computer is like a standard light switch. It's either on or it's off, 1 or 0. If you want something like half light, you have to flick it on and off super, super fast to create the illusion. An analog computer, on the other hand, is like a dimmer switch. It can smoothly and naturally represent every single level of brightness in between. It builds a mini version of a physical system inside the chip and just lets it go, getting the answer at literally the speed of physics. This quote from the source material just hits the nail on the head. It's perfect. There's no back and forth, no fetch, decode, execute cycle like in a digital chip. The physics of the electricity flowing through the circuit is the calculation. It's elegant, it's immediate, and it uses almost no energy. Now, I want to be super clear here. We're not talking about dusting off some clunky 1950s machine with glowing vacuum tubes. Modern engineering has completely reinvented analog for the digital age, and in the process, it's solved its biggest historical problems. Okay, so let's tackle the elephant in the room. The big knock on analog, the reason we abandon it, has always been its imprecision. And you know what? That was a fair criticism. Noise and drift were total deal breakers back in the day. But here's the brilliant part. Today's systems aren't purely analog. They're clever hybrids. They use the raw, hyper-efficient power of analog to do the really heavy mathematical lifting, but they have digital controls and error correction algorithms working right alongside, constantly checking and steering the results to keep them precise and reliable. It's truly the best of both worlds. And the results? I mean, they're just mind-bending. Some of these new hybrid analog chips are promising up to 1,000-fold, that's 1,000 times, improvement in energy efficiency for certain tasks. That's not a 10% gain. It is a game-changing, revolutionary leap forward. And this isn't just a lab experiment. This technology is already out there making a real impact. It's making it possible to run powerful AI on tiny little devices at the edge. Think smart sensors that can run for months on a tiny battery. It's helping us build more accurate climate models, solve nightmarish logistical problems for shipping companies, and is even being used in critical national defense applications. Let's make this even more concrete. Look at this. For a really difficult optimization problem, a top-of-the-line digital GPU, something like an NVIDIA A100, might churn away for hours to find a good solution. A new analog chip? It can get there in seconds, and it does it while being 1,000 times more energy efficient. That's the difference between waiting half a day for an answer and getting it before you finish your coffee. So, what's the big picture here? What's the main takeaway? The key thing to understand is that this is not about analog replacing digital. That is absolutely the wrong way to think about it. The future is all about collaboration. Think about what happened with GPUs, right? For a long time, everything in a computer was just handled by the CPU. But then we realized GPUs were way better at certain things, like graphics and parallel processing. Now, no one can imagine a powerful computer without one. We're seeing the same thing happen again. Analog processors are becoming this new, essential, specialized tool for the kinds of problems that look a lot like physics. In the end, what this incredible comeback story really shows us is that sometimes, to make a huge leap forward, you have to take a look backward. By rediscovering the elegant ideas of analog computing and merging them with the precision of modern digital control, we're not just building faster computers, we're building smarter ones. Ones that could unlock breakthroughs in medicine, give us better climate predictions, and lead to AI that can work anywhere, for everyone, without wrecking our power grid. We're building machines that compute in a way that's more aligned with the natural world itself.